Hi there, everyone, and welcome to the digestive lab tutorial. Again, with the digestive system, there's lots to cover, but for this particular video, we're going to focus a little bit more on the lab practical aspect. What we'll end up focusing on is the pancreas primarily. Okay? So, just to do a little bit of, again, a quick review, we'll start with the pancreas itself. So typically we got the head, neck, and tail of the pancreas. Kind of looks like something like that, general shape. And of course we'll have our duodenum close by, usually depicted something like that, which we'll roll with there. And then last but not least, in close approximation and essentially being utilized at the same time or same very close in function, therefore close with structure, is the gallbladder, the common bile duct, hepatic duct, and the pancreatic duct, right? So we have the ampulla of Vater, which is great name. Definitely giving a bit of a Star Wars vibe there. And the main part that we're kind of focusing on would be the pancreatic ducts, right? And they just kind of drain into the duodenum that way. But again, just for proximity and getting situated and orientated, a little bit split back up this way. Have something like the gallbladder up there. Okay, and obviously the hepatic bile duct and the common bile duct meet right there. Okay. And sorry, just for a little bit more completeness, if we were to just kind of put in again the proximity, we'd have the liver kind of situated like that a little bit. Okay, just kind of filling out that space. Okay, so we got a little bit of a orientation here on what we'll find structurally. Yeah, and again, there's kind of two components to the pancreas, exocrine and endocrine, and it's primarily actually an exocrine organ. About 95% of the pancreas is exocrine tissue. So that's to say it produces secretions that aid in digestion. Okay, and it actually produces about a liter worth of enzymes, digestive enzymes, every day. So if you look at a liter milk jug or something, or in your fridge, that's how much pancreatic secretions you're making daily. So it's quite a bit. Right, and so we have kind of three main types of secretions, I guess categories that are used for digestion. That's our amylases, which breaks down sugar or carbohydrates into sugar, so you can digest it. And if you kind of lack in any of these digestive enzymes, you usually get different types of stools, either like diarrhea or loose stools or something like that. So, for example, with amylase, if you don't have enough that and or bile salts to help break down fats into fatty acids, you can kind of have fatty stools and stuff. But the other issue with lipase, if you don't have enough, would also be you don't absorb or tend to absorb like cofactors. So if you're talking about like vitamin A, D, E, K, those are all fat soluble vitamins. Your body won't be getting enough of those, right? So again, that works together with the bile release from your liver. So Okay. And then last but not least would be the digestive enzymes of proteases. So there's two. There's trypsin and chymotrypsin that are secreted to help break down proteins. And those are really important. For example, if you have some bacteria or something that somehow has made it through the stomach, kind of helps digest those a bit more. But as always, it's a great question to kind of ask, how does our body know? Like, how do we know when to secrete, right? And when we're dealing with physiology, regulation and feedback loops, really, really important. So one of the things to consider would be as far as regulation of secretion of these digestive enzymes. And one of the main components is actually neurological. Now, it happens in combination from a secretion. It's not a hairdo, that's a brain. Would be along the lines of, let's go to purple here. So we have these cells called eye cells, and they're kind of just for general proximity, you can say they're lined here along the duodenum. Okay, so with these eye cells, what will happen is you'll have your foods or content or chyme released from the stomach, and at that point in time, we have peptides, amino acids potentially as well. And probably even because it's after, the release of bile into the duodenum, you're also going to have fatty acids. Okay, and what they're going to do is they're going to trigger these eye cells to both have a hormonal release into the blood supply locally, but also along a vagal nervous connection. Okay, so the nerve's going to head up, and there's this thing called a vasovagal reaction or signaling that essentially will cause the release of pancreatic digestive enzymes. So again, that's essentially stimulated from food stuff or chyme and entering into the duodenum, and this is through CCK or cholecystokinin. Cholecystokinin, CCK. Yeah, and that stimulates both the neural and hormonal pathways that help stimulate the release of pancreatic digestive enzymes. Okay. So that's a bit on the strictly digestive part. If we go a bit more towards some energy release, so how do I want to do this? Let's see. Let's scroll back up here. I think it might get a little messy, but hang in there. Okay. So let's go red. Okay, and let's get let's get rid of this. Okay. So we're gonna move over to some blood sugar levels, okay? And how do we digest how do we regulate that? So one of the ways we're looking at that is, let's say, we'll just say G for glucose levels, okay? So what we'll have is, sorry, just trying to get my colors coordinated here. Okay. So blood glucose is really, really important to have in a homeostatic or a controlled range, primarily one for function, making sure that we have the appropriate amount of energy available to our muscles, but and brain and etc. But it's also a bit of a protective mechanism to have this control so that we don't get too much sugar in our blood, because that can be detrimental to functioning of brain and muscles and various functions that can get overwhelmed by too much blood sugar. So how does this work? Well, so we have some sort of set amount of glucose in our blood. So typically what we're looking at is anything. So the units are milligrams per deciliter, or what your lab will be using for data, it'd be millimoles per liter. And usually you're looking at a range where you want somewhere between 4 and 10 millimoles per liter. Okay. Great. So how do we do this? Well, there's these cells in our pancreas for let's say when our blood glucose gets too high. Okay, so let's try to use one color all the way through on this one. Sure. Let's use a wilder color. Okay. So when blood glucose gets too high, so we're gonna say close, we're gonna get close to 10 or above. What will happen is we have these beta cells in our pancreas. Again, there's not too many, but they'll release insulin. Okay, so beta cells equals insulin when they sense that glucose is too high. And typically what they'll actually do is they'll get released into blood and stimulate the liver primarily to release insulin into the blood. So you have this insulin cruising around, and what it does is when it interacts with cells, is it causes the cells to uptake glucose from the blood. So again, when glucose is too high, and the way I think about this is insulin encourages cells to bring glucose in. Insulin, glucose in. So if we have some cells kind of here, right, it's going to encourage glucose to go into the cells, and therefore the effect will be bringing glucose levels down or back within homeostatic range. But let's say, and this can happen sometimes in healthy individuals or just generally speaking, definitely in diabetics where there's poor control over this homeostasis. Let's say glucose levels fall too low. Okay, so all of a sudden now there's not enough glucose in the blood. Okay, so now we're starting to have a lack of sugar energy. Well, one of the things that will get stimulated are alpha cells in our pancreas. And what that will do is release something called glucagon. Okay, so we get a glucagon release, and essentially what that does, again, it also travels to the liver. Okay, common theme here where stored sugar lives, right, as glycogen. Probably recognize that from other classes. Glycogen. Okay, so that's stored glucose. And what it causes that to do is that will get released into the blood as glucose. Okay, so again, glucagon, now it's glucose. And what that will do is help find homeostasis for blood sugar levels again. Okay. Great. So, I guess in short, blood glucose goes up. We release insulin to bring glucose in to the cells. On the opposite end, glucose falls. We want some glucagon out of the liver into the blood to bring glucose levels back up. Okay, little way that I usually think of that to remember it. Okay. Great. So we've covered the kind of regulation of blood sugar a little bit. One of the few points that I want to bring up in regards to factors that will affect blood sugar are there's a few things. So the first one is the difference between glycemic load, glycemic index. So glycemic index is this number of 0 to 100 that essentially says how much of a reaction relative to pure sugar does your blood sugar peak at. Okay, so it's kind of this absolute number just relative to sugar. Sugar's 100. Everything else kind of falls under that in some capacity. But it doesn't necessarily depict the full story as far as how our bodies respond to food being ingested. So part of what happens with that regulation or digestion of food is we have different rates and durations at which carbohydrates can affect our blood sugar. And so a better index to typically look at would be something called a glycemic load. So GL, they have charts with glycemic index and glycemic loads for you to look at. And you'll notice some foods, for example, will have like a fairly high glycemic index, but not a huge glycemic load. So what that means is you might hit a fairly high level as far as how much it'll affect your blood sugar, but the duration or how quick that amount of carbohydrates gets into your bloodstream might take a really long time. So conversely, typically you want to look for lower glycemic foods, right? Okay, so that kind of comes up in our experimental conditions there. And partly what that can be relayed to a little bit is it does matter what sort of order or types of foods that you consume to affect your blood sugar levels. So what do I mean by that? Well, for order, I mean if you eat vegetables and proteins before you have your carbohydrates with your meal, and I don't mean fiber or some of the carbs, low-level sugars that might be in vegetables, but like a real sugary pasta or something like that, you can actually decrease the glucose levels or your glycemic load in your body by anywhere from 20 to 40%. And that's over the duration of 30, 60, and 120 minutes post-meal. So definitely comes into effect. Similarly, and maybe counterintuitively, liquid foods tend to also decrease the amount of glycemic or blood glucose levels experienced, which is interesting as well. And that typically depends on what's in the mixture of whatever you happen to be drinking. So there's been a couple of interesting studies looking at that. And I think the last point that might be helpful, I mean, aside from looking into why and how exercise or different types of exercise might stimulate release of glucose into the blood, is the fact that normal healthy individuals can have moments of fairly high or relatively low blood sugar levels, and it's usually pretty rare if this was to occur. But there's a few reasons why that non-diabetic people might have these episodes. And typically, if you're doing measurements, it usually comes down to a couple of things. So one is blood volume, so plasma. So if you think back to how we measure like the path or the route at which blood glucose is measured, especially with the method for this lab, and there's a video with this. So essentially you just have this needle sitting in venous blood, and it's kind of closed off because of the sticker pod thing that goes over top of it. But what can happen is it's not measuring arterial blood. So there's a difference between arterial blood and blood glucose levels and venous blood. If you think about it, venous blood is after it's been utilized by all your cells, so it's kind of past. So it makes sense that if, say, your muscle cells are using sugar for activity, or blood glucose from your blood, then when it gets to past your capillary beds where the exchanges happen, it's going to be less likely that there's going to be as much glucose in the blood there. So what you find is in plasma levels, so the fluid or liquid part of blood, as well as in particular in the venous side of blood measures, that they can be quite a bit lower. And that again arises in individuals who are non-diabetic and potentially right after a meal or right after exercise. You can see that. So there's this kind of hyperinsulinemia where you see this exaggerated decrease in that levels of glucose in the blood after those events. Similarly, if for whatever reason your volume happens to change as well, that can affect the ratio of millimoles per liter. Okay. Great. So with that, have fun exploring the effects of exercise and different types of food on glucose levels and blood glucose levels, and we'll look forward to seeing the lab reports.